Good morning once again. Today I am going to start with another lecture, that is next method, principles of, that is three moment equation. Three moment equation or Clapeyron's theorem. So this theorem is nothing but it is based on the principles of superposition. It is based on the principles of superposition. You have to separate all the moments, and you will add all the things. So first thing, the equation is, for example, you have a continuous beam with three unknowns here. The dI value, that is r minus r, that is redundancy, which will be equal to, here there are three equations, so 3 minus equilibrium equation. You can see that there is no horizontal forces here, so summation of vertical force equal to 0 and summation of moment equal to 0. There are only two equilibrium equations, so 2, redundancy is 1. I have to find out the one equation. So you can see that I am going to apply a UDL in this span and a central point load of W in here. So W and W. So how to solve this? You have to find out, let's say this is A, this is B, and this is C. So the distance is it is L, this is L1 and this is L2, and also here the E value is E1 and I value is I1, and here it is E2 and I2. So it have two different materials, so E1 and E2. It have two different lengths, so L1 and L2, and it also have two different cross section area, that is I1 and I2. So here you can see that it is a UDL W, and here it is a point load capital W. So how to solve using three moment equation? So what is three moment equation? First thing, we have to remove the moment. You can see that at this point, that is the A point and B point, always bending moment is equal to 0. You already know that at the ends you have bending moment equal to 0. But in case of C, bending moment is not equal to 0. You will have a bending moment. So we have to analyze this as, so first thing, remove these external loads and consider the moments. So this is MB, this is MA, and this is MC. You can see that for this span, that is for a second span, the moment is anti-clockwise direction, and for the left side it is clockwise anti-clockwise direction. So both the magnitude is same, that is MC, but the direction differs for left side and right side. So this is a support reaction. So this is the fixed end moments. These are called as fixed end moments. So how we have to find out this MA, MC and MB? Already you know that moment about A and B is equal to 0. That is M at A, and that is MB will be equal to 0 and MB is equal to 0. So only you have to find out MC value. After that, after finding the MC value, we can find out the RA, RB and RC values. So how to find out? So this is the three moment equation I am going to write now. So what is the three moment? First we have to take part at C, at the junction C. So I am going to write three moment. So you can see that when you take at this point, you have to take the moment at that point and the previous and the next. So these three moments will be involving in this equation. So what is the equation? MA L1 by E1 I1 plus 2 times mb L1 by E1 I1 plus L2 by E2 I2, then plus MC L2 by E2 I2 plus 6A1 x bar by E1 I1 L1 plus 6A2 x bar by E1 I1 L1 plus 6 delta 1 by L1 plus delta 2 by L2 equal to 0. So this is called as three moment equation. This is called as three moment because it involves in three moments. Sorry, this is MC here and this is MB here because we are taking about C point. So you can see that MA, it involves in only one span, that is only on its right side. So it is L1, E1 and I1. For MC, so for the C point you have two spans, that is one is on right side, another one on left side. So right side it is L2 by E2 into I2. For the left side it is L1 by E1 I1. You can see it is so that is time, it is 2 times multiplied because you have two moments at this point. Then MB, here it is only 1 MB, so only one side, that is left side, L2 by E2 I2. So this is a basic three moment equation. In addition to that, based on the principles of superposition, you have additional loads here, that is the point load and the UDL. So due to this external loads, you will have some reactions. That reaction, that moment is called as 6A1 x bar by E1 I1 L1. So for the span 2, it is 6A2 x bar by E1 I1 L2. What is this area? It is the area of the bending moment diagram for that span only. It is the area of bending moment at that particular span. For example, if it is in second part, then this area. So what is the bending moment here? You can see that we have to consider it as a simply supported beam. This is a simply supported beam and here it is a simply supported beam. So the bending moment will be, for point load it will be always a triangle load, and for this it will be always a parabolic load. For UDL it is a parabolic load. So and this point will be equal to W. So and this value is nothing but it will be so this is W L square by 8. So this peak value, and this peak value is nothing but W by 2 into L by 2. So W L by 4. So this is the peak value of the point load, and this is the peak value of W L square by 8. I will describe in a tabulation form for all these things, and you can easily assess things. Okay, so this is the area. We have to find out, this is area 1 and this is area 2. And what is x bar? So you are going to take the equation at this point. So CG point of this, and this will be x2, and CG point of this is here, and this will be x1. So you have to find out this x bar 1 and x bar. So this you have to find out, and area you have to find out. So divided by 6 into EIL. This is the equation for this external moment to consider in the moment. And then this part is nothing but, you can see that always it will not be in a straight line. Sometimes this point may be reduced to a dropped location. That is, initially the B is not here, initially the B is here. That is, when you construct, you have some problem in construction, so that this support will move downwards automatically due to sinking of the support. It is called a sinking of support. That is the moment of the B. Initially the position is not here, it is here. In that case you can see that it will be turning like this, and initially there will be a stress developed here. That stress is moment is called as delta 1 by L1. Delta 1 is the sinking, it will be given in the question. Delta 2 will be given in the question. If not given, this is equal to 0 and this is equal to 0. If only when the sinking is given, it is considered, otherwise it is considered as 0. If it is in the downward direction, it is considered minus, and in the upward direction it is considered as plus. So this is the 3 moment equation. You can see that here there is only one unknown. So with this equation, you know, here MA is equal to 0 and MB equal to 0, and also for this area you have to find the area and substitute here, and then delta values here. So with this I will explain with another example. So this is the method how to find out. You have to substitute here in the formulas and find the unknown reactions. You can see that if another point load is here, say it is a D point, so you have to make one equation here and make another equation here. So in this case it will have two things, and also here you will have another load. You can see that there will be another two loads here. You don't know now MB, but here D value will be equal to 0, here it will not be equal to 0. So you don't know MB value and MC value, so you have to form two equations, one equation at C and another equation at B. So with these two equations, solve and find out for MC and MB. So this is a method of 3 moment equation to solve the extra unknown reactions. This is also known as Clapeyron's theorem. So based on this, I will give the next lecture, that is a numerical problem. Thank you.